I found Dr. Loeb actually somewhat by accident. I was watching CBS News, and there was a piece about his work on this interstellar object. And I hope I'm pronouncing it right. Oumuamua. Is that how you pronounce it?
Oumuamua.
Oumuamua. And I realized that I had a little something in common with Dr. Loeb. Dr. Loeb actually hails from Israel. My wife is Israeli, and I trained at Harvard. I thought, why don't I just give him a quick buzz and drop him a line? I found his email address online, and he was kind enough to agree to give a talk for us this evening. Dr. Loeb is the Frank Baird Professor of Science at Harvard University and the chair of Harvard's Department of Astronomy. And he's the founding director of Harvard's Black Hole Initiative and director of the Institute of Theory and Computation, ITC, within the Harvard Smithsonian Center of Astrophysics. He also chairs an advisory committee, a Breakthrough Starshot Initiative, and serves as the science theory director for all initiatives of the Breakthrough Prize Foundation, as well as the chair of the Board of Physics and Astronomy at the National Academies. He's the author of 4 books and over 700 scientific papers. Dr. Loeb is elected a fellow in the American Academy of Arts and Sciences and the American Physical Society and the International Academy of Astronomics in 2012. Time selected Dr. Loeb as one of the 25 most influential people in space. Dr. Loeb, I want to say shalom, welcome. We really enjoy having you. It's very special to have someone of your stature at our talk, and I'll shut up and let you get on with your talk. Thank you so much for joining us.
Welcome.
Thank you for hosting me. That's a great pleasure. And I should, before I start with my presentation, I should say that you could have just described me as a farm boy. I do not pretend to be more than that, and all the titles that you read are just a byproduct of work that I've done, but they, as far as I'm concerned, they are not that significant. I think the way I see science is as an extension of our childhood curiosity. And I remember a very vivid memory of my childhood when I used to attend dinner and ask a very difficult question, and the adults in the room would pretend that they know the answer. And that was the good situation. The bad situation was when they didn't even pretend to know the answer. They just dismissed the question because they didn't know the answer to it. And I thought that by becoming a scientist, I would be surrounded by like-minded people and be able to pursue questions based on evidence that we collect. As you will hear in a few minutes, that was not necessarily the case. It seems like this subject that I will describe has a lot of pushback in the academic community, whereas even the government, which is the most conservative organization that I'm familiar with, accepts it as a viable pursuit. And in fact, the Congress decided just this month on establishing an office to study some of the objects that I'll describe. So let me share my screen, and I'll make a presentation that I'll make it as brief as possible so that we will have time for as many questions as the audience would like to ask. This is the shortened version of my presentation. And what I'll focus on is the book that I published earlier this year, popular level book called Extraterrestrial, that you see in the middle of this slide. And if I had to summarize it in one sentence, I would say, when you're not ready to find exceptional things, you would never discover them. What you see on the right-hand side is a textbook that I've written, published in June this year, just a few months later, that is titled Life in the Cosmos. And it's more than 1,000 pages long, published by Harvard University Press, and it focuses on establishing the scientific foundation for this frontier of searching for both primitive life in the form of biosignatures up to intelligent life in the form of technological signatures. And what you see on the left side is a a photograph of a picture that was hung on the walls of the Berlin Brandenburg Academy of Science and Humanities exactly a year ago. It was taken by the German photographer Herlinde Quilbel, who came to my office at Harvard a few years ago and asked me to write on the palm of my hand the question that I regard as most significant in science. And I wrote, "Are we alone?" Now, the one thing I learned over several decades of practicing astronomy is that we should be modest. The universe teaches us modesty. And we've made the mistake several times before that, we collect most of the information about ourselves and then we get attached to ourselves and we believe that we are at the center of the universe. And that was what the ancient Greek philosopher Aristotle argued. And for 1,000 years, people believed him because it flattered their ego until Copernicus and Galileo argued otherwise. And we know that there were philosophers that put Galileo in house arrest, telling him that they don't want to look through his telescope because they know that the sun moves around the earth. But if these philosophers were to design a space mission today, they wouldn't be able to have the rocket meet its destination because they would have the wrong concept about the motion of celestial bodies around the earth. So nobody remembers those philosophers, even though at the time they were very powerful. And if they were to live today, they would have canceled Galileo on social media. Now, the other thing we know is not only we are not at the center of the universe, but in fact, even what we find in our backyard is not privileged in any way because half of the sun-like stars seem to have an Earth-sized planet roughly at the same separation. That's what the data from the Kepler satellite indicated just last year. So altogether, there are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. So when you see a painting like the one in this slide of an alpha male that used to be an emperor or a king, was very proud of himself because he conquered a piece of land here on Earth, that's not more impressive than an ant hugging a single grain of sand on the landscape of a huge beach. But I can understand where it's coming from, this sense of arrogance, because when my daughters were young, they thought that they are at the center of the universe and they are the smartest in the world until we took them to the kindergarten and they met other kids. Obviously, our civilization will mature by finding others. And most stars formed billions of years before the sun. We know that by observing the star formation history of the universe. So that means that if half of the sun-like stars have a planet roughly like the Earth, that there could have been, very likely, there could have been a civilization that was technologically advanced like we are, or even more, 1 billion years ago. And we are currently developing artificial intelligence systems that drive cars. And in a decade, we might even send AI systems to space because humans are not designed to survive in the hazardous conditions of space. We were selected by Darwinian evolution to survive on this rock that we call Earth, but not in space when we are exposed to energetic particles and energetic radiation. So we might decide that it makes much more sense. In my view, actually, I attended a panel discussion just a month and a half ago in the Washington National Cathedral, where Jeff Bezos argued that he would like, the way he sees the future with space tourism is to establish a platform in space where millions of people will live, or perhaps up to 1 trillion people will live, and the Earth would be regarded as a national park that you visit every now and then. To me, the health hazards of space make it very unlikely that we will ever go there and establish a sustainable environment. It makes much more sense to send AI systems, and we should be proud of them. They are just like our technological kids. So I don't think we should be more proud of sending a human being, especially when it's very challenging for that human being to survive there, rather than risk the health of many people. We might as well send AI astronauts. And if we imagine sending AI astronauts, someone else might have done that 1 billion years ago. And those AI astronauts could be equipped with 3D printers that would repair damaged parts or reproduce themselves. So within 1 billion years, you can pretty much populate the entire Milky Way galaxy. So is this the reality that we live in? Is there equipment floating in space that we haven't noticed, coming from another technological civilization? And it might have AI systems in it. So it might be very smart without biological creatures, just equipment. Because 1 billion years is enough time to reach everywhere in the galaxy, even with chemical rockets that we now possess. So the way to find out, this is not a philosophical question, by the way. Just like whether the Earth moves around the sun or the sun moves around the Earth was not a philosophical question in the days of Galileo. We can find the answer to this question not by thinking very hard, but simply by looking through our telescopes. It's very simple. Now, you have to understand there is a world of ideas which represent all possible virtual realities, a lot of possibilities that reality could have been like. And usually when we think about these virtual realities, we prefer to select those that flatter our ego. So if there is a virtual reality in which we are at the center of the universe, we are the smartest, there is nobody else but us, then obviously we would prefer to choose that virtual reality as a representation of our reality and to ignore as many facts as possible so that we will continue to believe in that. Just like my daughters would have preferred to stay at home and not go to the kindergarten. But the point is that will not change the reality that we live in, that we all share. You can put goggles on your eyes the way Facebook advocates now and imagine that you are in the jungle, that you are in a you always look thin, and you will enjoy, you will get a lot of pleasure from that virtual reality. But it's not the reality that you live in, that we all share. And physics is about finding that reality. So anyone that insists on the notion that we might be alone, we might be the most intelligent in the universe, and that any other claim is extraordinary, and therefore we should not invest funds in extraordinary claims because we need extraordinary evidence before we will invest the fund. That's a circular argument. The correct approach is to say extraordinary evidence requires extraordinary funding. We invested $10 billion in the Large Hadron Collider to search for supersymmetric particles that make up the dark matter in the universe. We haven't found them. $10 billion. That was part of the mainstream. Physicists were arguing, they are just around the corner, let's go and find them. Other physicists were arguing the dark matter is weakly interacting massive particles, let's go and find them. So hundreds of millions of dollars searching in the dark for 4 decades, we haven't found it. And how significant would that be to the daily lives of people? Not much. If the dark matter is weakly interacting massive particles, people will continue their daily life. We haven't invested anything in searching for technological equipment floating in space. And yet the mainstream claims that this is an extraordinary claim that doesn't have extraordinary evidence. Now, without $1.1 billion invested in the LIGO experiment, we would never find gravitational waves. So it's a circular argument to basically say there is no extraordinary evidence, therefore we should not discuss it, because you maintain your ignorance, just like the philosophers arguing, let's not look through the telescope because we know the answer in advance. And the Galileo project that I established in July this year is basically trying to break that mold and not repeat the mistake of the philosophers. Basically find the answer by looking through telescopes instead. Now, the first object that astronomers noticed from outside the solar system was indeed found in 2017 by a telescope in Hawaii called Pan-STARRS on the summit of Haleakala in Maui. And the object was given the name Oumuamua, which means a scout in the Hawaiian language. And I was interested in it because a decade earlier, I wrote the first paper that forecasted how many rocks do we expect from other stars going through the solar system. And we didn't expect Pan-STARRS to find any. By several orders of magnitude, it was off. Suddenly there was this object that nobody expected. So the astronomers said, oh, well, this object that is circled in blue here is probably a comet, because comets are the most loosely bound objects to the sun, and therefore they should be also for other stars. The only problem is it didn't look like a comet. Now, this object came from a special frame of reference called the local standard of rest, which is the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. And only 1 in 500 stars is so much at rest as Oumuamua was in the local standard of rest. So basically, it was like a buoy sitting at rest on the surface of the ocean, and the solar system, like a giant ship, bumped into it. And that's a very unlikely situation to be in for the first interstellar object. You expect it to inherit the motion of its parent star. That did not prevent astronomers from saying, oh, it may have come from this star, from that star. Well, none of the nearby stars is at rest in the local standard of rest. So it couldn't have come from the stars that people assigned it to. And we didn't notice it when it came closest to the sun. We only noticed it on October 19th, when it was already receding away from us. You can see the trajectory here. And then, of course, the sun gave it a kick, just like a racket gives a kick to a ping pong ball, except the sun did it by its gravitational force. And as the object was tumbling every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. That's a big factor. It meant that the size of the object projected on the sky was changing by a factor of 10 as it was tumbling, and that meant a very extreme shape. Most likely pancake-like, flat, a disc-like shape based on the variations of light that were modeled at the 90% confidence level. So there were several anomalies of this object. First, we didn't expect it to exist because the abundance of rocks based on what we know about the solar system is not large enough. It had roughly the size of a football field based on the reflected sunlight. It also originated from the local standard of rest. Only 1 in 500 stars are so much at rest as this object was in that frame. And it had a very extreme shape, most likely pancake-like. And then the Spitzer Space Telescope looked at it in great detail and did not detect any carbon-based molecules around it and put very tight limits on any evaporation of this object. It was clearly not a comet of the type that we have seen. And most strikingly, it deviated from an orbit that is shaped just by the sun's gravity. There was an additional force that was pushing it away from the sun. And that force declined inversely with distance squared, as if the mass of the sun was reduced slightly. So the attractive gravitational force of the sun was lower than it should have been. But since there was no outgassing, no evaporation, the only explanation that I could think of was that the push is generated by the reflection of sunlight. And that, in order for that to be effective, the object had to be very thin, sort of like a sail. So in a scientific paper, we suggested with a colleague of mine, with a postdoc of mine, that perhaps it's artificial in origin. The paper was accepted for publication within a few days, but of course, it received a huge amount of pushback from the scientific community, a lot of interest from the general public. So astronomers say it must be natural, business as usual. But the problem is that all the proposals to explain the anomalies of this object invoked something that we've never seen before. For example, a cloud of dust particles that is 100 times less dense than air, sort of like a feather being pushed by reflecting sunlight. We've never seen such a cloud of dust, a dust bunny. And moreover, when it gets close to the sun, it would have gotten heated by hundreds of degrees, and it would have been difficult for it to maintain its integrity because of its low material strength, if it's 100 times less dense than air. Then there was a suggestion, maybe it's a chunk of frozen hydrogen. So when the hydrogen evaporates, like in a comet, it's pure hydrogen and therefore it's transparent. We can't see it. The problem with that is hydrogen evaporates very quickly. So such an object would not survive more than a few million years. And so it cannot really traverse large distances across interstellar space. And you need to make it in molecular clouds. So it's very challenging to make enough objects close enough so that they would not evaporate. And then there was a suggestion, no, it's not molecular hydrogen, it's actually a nitrogen iceberg that was chipped off the surface of a Pluto-like planet around another star. And for that to be the case, you need more nitrogen than available in the Milky Way galaxy to make enough chips. So the mass budget just doesn't work out. So the fundamental question is, was Oumuamua natural or artificial in origin? And given that all the proposals made invoked something that we've never seen before, my view is that we should leave the artificial origin on the table and not just dismiss it. Because the situation is similar to walking on the beach, and most of the time you see rocks or seashells that were naturally produced, but every now and then you find a plastic bottle. And that indicates that there is a civilization out there. So perhaps Oumuamua was a message in a bottle, so to speak. And of course, you don't need the sender to be alive. It's just like finding a package in your mailbox. Whoever sent it may not be around anymore. And the Drake equation has nothing to do with this. The Drake equation deals with signals, like radio signals that we receive here on Earth, and it's just like trying to have a phone conversation. You need the counterpart to be active at the time that you're looking at it. But if you ask how many plastic bottles do I have on the surface of the ocean, they keep accumulating. So it just depends how many were produced and sent into that ocean. And all you care about, if you ask, what's my chance of finding a plastic bottle within a certain distance, it all depends on the number of plastic bottles per unit area on the surface of the ocean. Or in the case of equipment in space, it's the number density of pieces of equipment as a function of their size. And that's not the Drake equation. Now, a year ago, there was another object discovered by the same telescope in Hawaii that exhibited the same qualities as Oumuamua. Didn't have a cometary tail, and also it was pushed away from the sun by reflecting sunlight. It was given the name 2020 SO. There is a Wikipedia page on it. You can check it out. Within a few weeks after its discovery, the astronomers realized, actually, if you go back in time, this object came from Earth. It was a rocket booster that was launched in 1966 as part of a lunar lander mission. And it had thin walls. So we can understand why it was pushed away from the sun by reflecting sunlight, simply because it had a large area for its mass. And also we can understand why it didn't have any cometary tail, because it was made of steel. One thing is clear, it was thin, not for the purpose of serving as a light sail, but it was just thin for a different purpose. And moreover, it was artificial in origin. We know that we produced it. The question is, who produced Oumuamua? And finding Oumuamua, to me, is very similar to a caveman finding a cell phone. The caveman is used to playing with rocks all of his life. So if he were to find a cell phone, he would argue that the cell phone is a rock of a type that was never seen before, which is factually correct, except that it's not a rock. So if the caveman would behave just like many of my colleagues and say, oh, it's just a rock of a type that we've never seen before, a hydrogen iceberg, nitrogen iceberg, forget about it, let's move on, then that would be the end of it. The caveman would throw away the cell phone and that's it. No more evidence. But if the caveman would be curious and press a button and realize that this special rock can record his voice, and then press another button and realize that it records his image, then it will become clear that it's not a rock. And so what we need is indisputable evidence that an object as weird as Oumuamua is artificial in origin. It's not a rock. I mean, and you know, that is quite easy to demonstrate if you have a picture, because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book, Extraterrestrial. Obviously, I would not need to write the book if I had a high-resolution image of Oumuamua. I would just show the image and that will be it. And if the image looked like a nitrogen iceberg, so be it. We learned something new, that there are nurseries making nitrogen icebergs that we've never seen before at much larger quantities than the solar system made rocks. That's unusual. Or if it's a hydrogen iceberg, we would learn that there are these molecular clouds that produce these chunks of frozen hydrogen that we've never thought about before. Again, something completely new. I would be happy with that discovery if we had a picture of a hydrogen iceberg floating in space. And moreover, if it's just a fluffy cloud of dust particles, that would also be fantastic. But let's collect the evidence, and that's not a cheap endeavor, to send a spacecraft with a camera that will pass within 1,000 kilometers of an object like Oumuamua so that it can snap a photograph. That kind of a mission would cost $1 billion. And it's just like with dating. If you go on a date and you have to decide whether to make that person on the date your partner for life and have an offspring with that person, that's a difficult decision because you have to make sure that the person has the right genetic making, the right skills as a companion, and so forth. So it takes time. You need to collect that information. And the same is true about a date that costs $1 billion, like sending a spacecraft that will come close to an object like Oumuamua. You really need to make sure that it's weird enough to spend $1 billion on a shot like that. But that's one of the goals of the Galileo project. That's the space component of the Galileo project. And the idea is to come close enough to an object so that we can take a photograph of it. It's not very complicated. It's not a philosophical question. It's just taking a photograph. And you can see on the right side a picture that was taken by the OSIRIS-REx mission that went close to the asteroid Bennu and actually landed on it, and it will bring back a sample in 2023. Frankly, personally, I would love to land on a weird object like Oumuamua. And if it doesn't look like a rock, I would be very interested in pressing some buttons there. Now, in addition to Oumuamua, there was a report by the Director of National Intelligence to Congress that was delivered on the 25th of June this year, which mentioned unidentified aerial phenomena or objects that were detected by military personnel using multiple instruments and appear to be real. Now, what we see is just the tip of the iceberg of that data because most of it is classified. And I actually sat next to Avril Haines, the Director of National Intelligence, in the Washington National Cathedral. And it was very interesting to hear her perspective. And it was clear that the government doesn't know what to make of these objects. I think they're quite sincere about it. There are things we don't understand. Now, the scientific community ridicules and has a stigma on this subject. I don't think it's appropriate. If the government comes forward and says, we want to establish an office that will study these objects, we don't know what they are. You know, if they're not human-made, if they are not natural, if they are not drones, airplanes, birds, lightnings, then what are they? That's exactly a situation where the scientific community should say, okay, we can become relevant, we can help society figure this out. And that's an exciting proposition because science doesn't need to be boring. Science can be exciting. Science is supposed to serve the society at large. You know, we did it in the context of the mRNA vaccine for COVID-19, you know, and why not in this context? Why should this context be ridiculed? And so that was the second trigger for the Galileo project. Gladly, around the same time when this report was delivered to Congress, a few very wealthy individuals visited the porch of my home. And they were inspired by my book, asked me questions about it, and donated about $2 million to my research fund without me doing any fundraising. So I decided to establish the Galileo project, which involves a team of more than 100 scientists by now, 120 or so. And it will build telescope systems that will collect data that will be open to the public, just the way science is done, rather than the data being classified because it was collected by classified sensors. And then we'll figure out what the nature of these objects is, either the UAP, the unidentified aerial phenomena, or Oumuamua-like objects by dating the next Oumuamua. So this is the basis for the Galileo project. We dare to look through our telescopes for the answer. And my point is that extraordinary conservatism leads to extraordinary ignorance. So as I mentioned, the Galileo project will follow two avenues of research, UAP and interstellar objects. And one thing to keep in mind is that a meter-sized telescope, which by the way costs about $500,000, you can find it on the internet and you can click add to the bag for $500,000. Apparently there are people willing to pay that. So a 1 meter sized telescope can obtain a megapixel image of a human-sized object at a distance of a mile. That's quite impressive. It's not the cell phone cameras that will resolve such an object. You need to use instrumentation that astronomers use. And the idea is to use, basically take a video of the sky, both in the optical band, in the infrared band, as well as in the radio and audio, and resolve a label that says made on exoplanet Y and distinguish it from a label that says made in China, made in Russia. And the second component is more expensive, and that's the space mission to date another object like Oumuamua. Currently, we have $2 million. The goal is to raise $100 million for the UAP component. That will allow us to build hundreds of telescope systems that would cover enough of the sky to get good statistics on UAP. And then the space mission would be even more expensive than that. And by the way, this project was mentioned this morning on the Today Show. If you just go to Twitter or Google it, you will find the video from the Today Show on NBC. So there is this paradox that is named after Enrico Fermi, the famous physicist who 70 years ago went to lunch in Los Alamos together with colleagues, and they talked about extraterrestrial civilizations. And then he said, well, if they're out there, where is everybody? Now that is very pretentious. It's just like sitting at home and saying, nobody is knocking on my door, therefore I don't have neighbors. Well, to see your neighbors, you very often need to look through the windows, and better with a telescope. And so rather than ask, where is everybody, you should say, how do we fund the search for objects that may have arrived from other civilizations? And, you know, if you don't use a fishing net, how can you catch any fish? Or if the holes in your fishing net are bigger than the size of the fish, you will never notice them, which is pretty much the situation that Enrico Fermi was in. Now, of course, there were various suggestions for why they may not be visiting us. Like, for example, they may be dead. We can't detect the signals from them because of the short window of opportunity, and so forth. But in general, we should engage in archaeology, searching for objects that came from other civilizations in space. And my hope is that by finding relics of more intelligent species, we will be inspired. Because if I look at human history, the most common theme that I see repeating again and again all over is a group of people trying to feel superior relative to other people, causing a lot of damage. And the best example for that is the Second World War, where the Nazi regime triggered the death of 75 million people worldwide. That is 10 times more than COVID-19 so far. And we've been talking about COVID-19 for almost 2 years now. So 10 times more than that, triggered by a group of people that decided to feel superior relative to other people. And my hope is that by finding a smarter kid on our cosmic block, we would realize that all the differences among people are really insignificant. There is someone much smarter than we are out there. And so we better treat each other as humans like equals, equal members of the human species. Thank you.
Thank you very much, Dr. Loeb. We have a number of questions that have come in the Q&A area. I've asked some of the folks to hold off on, we weren't going to interrupt your talk, but I'll read some of them to you and hopefully you can respond. And by the way, wonderful talk. Thank you very much.
Thank you.
Here's a question from Joe. I don't know Joe's last name. Let's see. There's an article titled "The Natural History of Oumuamua" that gives a natural explanation about Oumuamua's strange things. The structure of the article seems to be trying to debunk Professor Loeb point by point. Does Professor Loeb know about that article? Would he like to comment on it? And he listed a URL, which I can post in the main chat for you to see.
Well, I don't need to see it. I know the paper. And
okay.
This paper came out more than a year and a half ago. And it was basically a collection of astronomers that worked on rocks in the solar system for many years, many decades. And they basically argued Oumuamua is natural, period. Now, they didn't really address my points point by point, because many of the points that I made in this presentation were realized later on. Now, the thing about this paper is that it claimed there is no problem with the anomalies. Oumuamua must be natural, period. That was it. It was a review paper by a lot of experts on rocks. And then a few months later, there was a paper saying, yeah, it is natural, but it should be a hydrogen iceberg. Now, the possibility of a hydrogen iceberg was not mentioned in that review paper. Nevertheless, there was a need for a team of mainstream astronomers to come up with a hydrogen iceberg scenario, because otherwise you wouldn't be able to explain the excess push of Oumuamua. So how could the group of people that said it's natural, period, how could they have forecasted the fact that a few months later, another group would say it's natural indeed because it's hydrogen? And then there was a problem with the hydrogen model. So another group came up with, it's probably a dust bunny. And then a few months afterwards, it should be probably a nitrogen iceberg. And then everyone cheered and said, yeah, natural, it's a nitrogen iceberg. But my point is, just a year before that, before these three suggestions were made, there was this review paper that said it's natural, period. So if it was obvious that it's natural, why did these three mainstream teams have to publish papers, multiple papers, perhaps 6 papers altogether, on various alternatives of explaining those anomalies, if it was obvious to begin with that it's natural according to that Nature paper that was just quoted? That to me illustrates the fact that it was not genuine. The claim that it's natural was not justified, because if it was justified, the other papers would not be published. Their phrase would say, why are you repeating something that is already known? No, these papers were written about a hydrogen iceberg, about a dust bunny, about a nitrogen iceberg, in order to explain the anomalies of Oumuamua, in order to say why you can use a natural origin to explain away the anomalies. But the original paper that was just quoted by the person who asked the question did not offer these explanations. Nevertheless, it claimed that it's natural. So how is it possible that different factions of the mainstream scientific community disagree about the interpretation when all of them say it's natural? It can't be always natural if you have to come up with something that we've never seen before, because all of these claims were, we've never seen before a hydrogen iceberg, we've never seen before a dust bunny, we've never seen before a nitrogen iceberg. So if it was obvious that this is natural in origin, why would anyone publish a paper talking about something that we've never seen before? That's a contradiction. And that has nothing to do with me. It just has to do with the fact that the original paper was not genuine. Because if they would have found an explanation that is genuine, then these other groups would not have needed to write the papers about a hydrogen iceberg, nitrogen iceberg, or dust bunny. So it's not as if that paper addressed point by point every point that I made and explained away the anomalies, because if they did explain the anomalies, those other 6 papers would not have been written.
Dr. Loeb, I had a quick question too. I want to ask you if you could just talk about your friend, Russian billionaire Yuri Milner, and him showing up at your place, and maybe a little bit about the Breakthrough Starshot initiative.
Right. He did not show up at my place.
Oh, I thought he had. Okay.
No. In 2015, which is many years, I mean, we are talking about long before the Oumuamua story showed up. He came to my office at Harvard, not my place. It's not it's not the same situation that I'm talking about here in the context of my book, Extraterrestrial. So that was a completely different context. He came to my office and asked me whether I'm willing to lead a project that will design a mission that will visit the nearest star within our lifetime. And
Alpha Centauri.
Sorry?
Alpha Centauri.
Yeah, the Alpha Centauri system. And within our lifetime, it means in 20 years. And for that, the spacecraft had to move at a fraction of the speed of light, because the distance to the nearest star system is 4 light years. So it takes light 4 years. So you need a spacecraft that moves at a fifth of the speed of light to get there in 20 years. And that's 1,000 times faster than chemical rockets. 1,000 times faster. So,
possibly a sail then.
So then the only technology that we could think of with my students and postdocs at the time was to imagine a very powerful laser shining on a thin film that would act as a sail and be pushed by the light of the laser. But this is a different context where we are trying to do something that will bring a spacecraft that weighs about 1 gram to the nearest star system in a short time. First of all, that spacecraft would move at a fifth of the speed of light because it's propelled by a very powerful laser. And second, it weighs only 1 gram. So we would never notice something like that passing through the solar system. You know, Oumuamua was the size of a football field. So it was about several tenths of times bigger in size. And it was moving at a percent of the speed of light, much less than the speed of light. If there is any object roughly the size of a person moving at a fraction of the speed of light near Earth, the astronomers would never notice it because it moves too fast. They would assume that it must be a glitch in their software. They are looking for objects moving much slower than that. And moreover, they can't see the sunlight reflected off an object that is so small. With the Pan-STARRS telescope, we reached the threshold of being able to see objects the size of a football field. But we cannot see objects smaller than that unless they come very close to us. So an object just passing within the orbit of the Earth around the sun, that is roughly the size of the starshot light sail, roughly the size of a person, would never be noticed. It doesn't reflect enough sunlight. And moreover, if it moves at a fifth of the speed of light, the astronomers would ignore it. So I would say, you know, it's possible that things like that are passing through. We just don't notice.
Great. Dr. Steve, you had some other questions there?
Yeah, there's a bunch that have popped up in the last few minutes. And I do know Dr. Loeb has a hard stop at the bottom of the hour, so we'll try to squeeze in a few more of these questions here. From Frank Statler, do you have any reason to be optimistic that the U.S. military or the National Reconnaissance Office will be willing to openly share hard data, like radar, for example, on some of these more compelling UFO incidents?
Yeah, that would be fantastic if they're willing to declassify data, but I'm just never optimistic that the government would be willing to do that because the data was collected by classified sensors, and we don't want our adversaries to know the capabilities that we have of monitoring our sky. And that's the reason the data is classified, even if it represents no threat, let's say, to national security. And if indeed the objects that were identified came from outside of Earth, it's an international matter. Okay, and science is best equipped to deal with international matters of this type. COVID-19 was an international matter. It didn't see boundaries among nations. So I think that one approach that was practiced over the years was to wait for the government to release the data. And, we make slow progress in that direction. The new office that will be established by the Congress will still continue to assemble, classify data and analyze it without releasing it to the public. It's under no obligation to release it to the public. So another path that can be taken is for scientists, for astronomers to use telescopes and look at the sky. Now you may say, okay, well, astronomers look at the sky all the time. Yes, that's true. But if a bird flies above a telescope, an observatory, the astronomers ignore it. And what the Galileo project is doing is developing a telescope system that was never built before. First of all, it's the first team of scientists engaged in the attempt to understand those objects that move much faster on the sky than any astronomical object. But we are using telescopes to first look at the entire sky all the time and find objects of interest, and then use artificial intelligence or machine learning algorithms to identify the type of objects we are looking at, whether they are birds, drones, airplanes, or something else. So we will need to process a lot of data in doing so. We will need to place a lot of copies of the same telescope system in many locations, hundreds of them, and then collect that data and analyze it, and it will be open to the public. So I am much more in favor of this approach, where we don't rely on the government. We don't need someone else to provide us with the information, because most of the sky is not classified. And it's about time that scientists get engaged in this question and clear it up. And, it's like a fishing expedition. We might catch only sardines. These are fish that are not particularly interesting, but so be it. If we explain away the population of unidentified objects in some natural context, that will by itself serve as an important contribution to society, because people will not speculate about them anymore. If we find that there are some rare natural phenomena, that would be something new that we discovered. And if we find that there are extraterrestrial, that would be remarkable. I mean, that would have a huge impact on the future of humanity. So given all of that, I think we should engage in figuring out the answer. And by the way, $100 million is not a lot of money for a scientific project. As I said, we invested $10 billion and only found the Higgs boson.
Thank you for that. There's another couple questions here. We've got a few more minutes left here. Question from Anna, no last name. 2 questions. Philosophically, what do you think it would mean for humankind if we were to discover intelligent extraterrestrial life? And number 2, I agree we should evaluate interstellar objects, but isn't Oumuamua one of the first interstellar objects that's been discovered? Isn't it unlikely for it to be non-natural, since by nature most items are found are natural?
Right. So for the second question, let me start with that. If indeed the number of rocks is small and cannot explain Oumuamua, then you might think that it may have been targeting us or the inner part of the habitable region of the solar system, and that would increase our likelihood of finding the first object to be artificial, because it has a purpose. It's not just a random object moving through space. So that, with respect to the likelihood, even if nature makes many more objects than technological civilizations do, which is, by the way, not guaranteed, because if you make self-replicating von Neumann machines, they could, in principle, make a huge population. Rocks do not multiply themselves. It's sort of like having biological species that reproduce, and through many generations, you increase the number of such entities by a huge factor. And rocks do not multiply. So if you were to make artificial objects that can reproduce themselves, then you can get many more. But to your first question, which is, I think, the most important question, it will such a discovery, even if most of the unidentified objects are natural in origin, it's sufficient to have one of them that is not, in order for it to have a huge impact on the future of humanity, because it will change our perspective about our place in the universe, about our aspirations in space. We could learn from such equipment because it will give us a leap to our future. Just imagine equipment that would take us 1 million years to produce ourselves. It's sort of like copying in an exam. We will learn from our neighbors that are much smarter about what we might expect in our distant future. And it could be worth a lot of money if we were to find it, because if you import the same technology to Earth, you're making a giant leap in technological terms. And so I think wealthy individuals, business people should take a risk and put the 100 million that we need in the Galileo project, because if we find something, they can benefit greatly from that finding financially. Not to speak about the benefits to humanity as a whole in terms of giving us a more mature view about our place in the reality that surrounds us. We would look back at the past as if we were completely ignorant, right? We were not even open to the idea that there might be something smarter than us out there. And suddenly we went out to the cosmic street and discovered all these packages in our mailbox. And they perhaps tell us something important. If we ignore them, it's just like ignoring a letter that you find too late in the attic of your home, a love letter that someone wrote that was never delivered to its destination, and it lost its timeliness. And perhaps there is a recipe for our future if we find one of these packages, something that would save us from ourselves.
I want to just make a comment on that answer. Many years ago when I was in college, I read Sagan's book, Contact, not the movie version. I actually read the book. And, Sagan had been saying things very similar to what you're describing, 20 or 30 years ago, in terms of, the degree of hubris we must all have to believe that we are the only living intelligent life in the universe. And I guess his comment was, wouldn't it be kind of a sorry state of affairs if that was actually the case? And he was very optimistic about the possibility of finding extraterrestrial life. But I guess the biggest problem with it that he cited was just the vast distances that have to be covered to actually verify that it exists to get there.
Yeah, but the point is there is a lot of time. You see, time in cosmology is measured in billions of years. So that means two things. One, that another civilization like us probably existed 1 billion years before us. We are not talking about 1,000 years before us. It most likely, if there was something like us or more advanced, it was 1 billion years ago. And that means they had a lot of time to develop far beyond our capabilities. And that so it would look like magic to us when we meet any relics from it. But moreover, it had 1 billion years to traverse these huge distances that
you're not saying in a galaxy far, far away, right? That's not what you're saying.
No. In our galaxy, most of the stars formed billions of years before the sun. We know the star formation history of the Milky Way. But also I'm saying that 1 billion years, if you take the size of the Milky Way and divide by 1 billion years, you get a speed that is needed to traverse it. That speed is much less than the speed of our chemical rockets. So even though there are huge distances, if you wait 1 billion years, you can pretty much go anywhere in the Milky Way. So that's the answer to that point by Sagan. But what I would like to emphasize is, that something that Sagan didn't know is that planets like the Earth around stars like the sun are very common. He didn't know that. And now we know that. So how can we continue to feel privileged? That's just inappropriate. And I think we should just search for evidence with a sense of humility. We should start from the proposition that we are not privileged in any way, rather than start from the proposition that we are alone in the universe and anything else would be an extraordinary claim. It should be the other way around. I would assume that we are not special, that things like us existed, and anything else would be extraordinary. And then let's just search for the evidence and figure it out, rather than boost our ego by claiming there is no extraordinary evidence as of now. And given that the public is so curious about this question, I think it's really inappropriate for the scientific community to evade this question. And by the way, it was Sagan himself that presented this standard: extraordinary claims require extraordinary evidence. I think it's just not the correct statement. The correct statement is extraordinary evidence requires extraordinary funding. And that's, and by the way, I'm not taking any funding away from existing projects to find the nature of the dark matter or whatever. These are private donations that would not have been allocated to science otherwise. And more than 100 scientists engaged in the project, many of them are young people that came to me and said, for many years I wanted to work on this subject, and there was no safe space because there is a lot of stigma and ridicule. And that has the biggest damage that it creates is for the careers of young people. They are really afraid of engaging in this. And you would think that academia should be open-minded, that it should take risks and innovate.
Dr. Loeb, I want to be very respectful of your time. You've given us a wonderful talk this evening. We do have a bunch of questions that didn't get a chance to get asked and answered, but we did promise that we would keep you to time. It is now 9:30. I don't know if you have any closing remarks you'd like to make, but on behalf of the Westport Astronomical Society, I really would love to thank you for your talk and your taking some of those questions. And I found it to be fascinatingly refreshing that there's someone out there who's willing to, be, in certain respects, play the contrarian and with a very positive spin on your positions in a way that not only makes sense, but makes it very enthusiastic, at least to me, that I can think a little differently and not be afraid of what the ramifications of thinking differently might entail. So thank you for that. Any final comments for you, sir?
Yeah, a few days ago, my publicist, the publicist of my book, said asked me whether I'm interested in celebrating some accomplishments of my book, some accolades that it got. And I told her that the heat generated by the publication of my book basically turned my skin to a material that is similar to titanium, that I don't get any pleasure nor pain from what other people think about me anymore. And what I really care about is this big question and its implications to society. And you have to understand, I'm a theoretical astrophysicist. I wrote by now more than 800 scientific papers in theoretical astrophysics. And despite the fact that I was trained as a theorist, I see the value of evidence as guiding science. And that's why I'm leading an experimental project. And I have a common language with instrumentalists. Just today, we had a meeting. We have about 6 meetings every week of the Galileo project. We're making a lot of progress. So actually, in the coming months, we are building the first telescope system on the roof of the Harvard College Observatory. And I feel at home, so to speak, with the instrumentalists, because this, as I said, is not a philosophical question. There was a philosopher who published at Nature Astronomy, a very prestigious magazine, about half a year ago, a paper saying Oumuamua must be natural based on philosophical reasoning. And I said to myself, haven't we learned something over the past 4 centuries that we should find the answers by looking through our telescopes? So anyway, it's not about me. It's about something bigger, a bigger question. And when I attended this forum with Jeff Bezos a month and a half ago, he was talking about the commercial benefits from space tourism. And I thought to myself, there is no commercial benefit to leaving the solar system, for example. You can't make a business out of it. The only reason to leave the solar system is to explore space. And that is led by a sense of spirituality, that there is something bigger than us. And that's why, there are lots of religious people that are fascinated by this line of research. In fact, there was a rabbi in Ann Arbor, Michigan, that sent me an email just a few months ago saying, I just gave a sermon on the Jewish high holidays inspired by your book, Extraterrestrial. And that was a revelation to me that this subject is so meaningful to people that seek spirituality, but it is. And there is something to space exploration that touches on the deep spirituality of the human spirit. And, I very much hope, I live not far from where Robert Frost lived. And he wrote the poem about the road not taken, that there were two roads in the woods that were available to him, and he took the path not taken, and that made all the difference. For me, taking the path not taken is most significant because there may be low-hanging fruit out there because nobody picked it up, nobody walked that path. So I very much hope that we will pick up the low-hanging fruit with the Galileo project in the coming year or two, and I'll be glad to speak about the fruits that we pick in the future.
Well, I would love to be able to have, if at a point where you are able and have some more data and you'd love to share, we would love to have you back here. Incidentally, a gift that my mother gave me when I went to medical school was exactly the Robert Frost book, because I left clinical medicine, went into bioinformatics, and have been there for the last 25 years. And bioinformatics was the road not taken from my perspective and her perspective. She's gone now, but this sits by my office up in my attic here with me for exactly that reason.
She was very, very wise. And I should say every morning I jog at 5 a.m. in the company of ducks, rabbits, wild turkeys, and birds. And I really enjoy nature. So I often take the road not taken.
Absolutely. And on that note, I'd like to make sure we are respectful for your time. Thank you so much, Dr. Loeb. For anyone who's interested, I believe this recording will be, I think the club has a place where we post this so you could watch it again. A number of people asked if they could watch this again later. Dan, I don't know, is this going to be on our YouTube channel, or will it be on another channel? Where will it be found?
It'll be on our YouTube in a few days.
Yep. We'll have it up there in a couple of days and you can watch it. We'll edit it up a little bit so it's just Dr. Loeb. So yeah, that was great. That was so much fun. Thank you, Steve, for booking that. Thank you, Dr. Loeb, and thank you everybody. And a happy Saturnalia and winter solstice and Merry Christmas.
One last thing, Dr. Loeb, I want you to know, I'm pretty sure you got the largest draw that we've had in a long, long time. We maxed out our Zoom account with over 100 people from as far away as Colombia, from India. We had folks online from Europe, places around the world where time didn't seem to exist for about an hour here, and they all tuned in to listen to you. So thank you so much.
Well, that's what gives me pleasure in doing this work. People like, for example, in the Washington National Cathedral, after the panel discussion was over, all the panelists left the room. These were very distinguished people. And there was a long line of 50 people waiting to tell me how meaningful is this research of the Galileo project for them personally. And I stayed there for another 45 minutes speaking with each and every one of them. So this is really what gives me the energy to ignore the pushback and just do what we are doing. Thank you.
At some point, I'll tell you what, I'd love to discuss Talmud with you and hear your perspectives on that in astronomy at some point down the road. Thank you so much, Dr. Loeb. Thanks everybody for tuning in for the Westport Astronomical Society's monthly lecture. And we will be returning next month. Have a happy holiday season. Be safe. Stay out of harm's way with COVID. And we will all be together again in about a month's time. Thanks so much, everybody.
Thank you, sir.